Today we're going to be talking about discrete probability distributions, and then this will take us from talking about discrete probability distributions into we're also going to be finding the mean and standard deviation of discrete probability distributions. So just to kind of review, a probability distribution just takes all of the outcomes of the probabilities that we're doing, writes them on the top row, and does the probabilities on the bottom row. So we're going to construct those first, and then we're going to use our graphing calculator. So get that ready if you don't have it out, and we're going to then take and find the mean and standard deviation of those probability distributions. Okay, so let's take a look at some of our definitions here. A random variable just has a single numerical value determined by chance. Rolling a die, flipping a coin, picking a card. Those are random variables. They all happen by chance. So we call those random variables. A probability distribution is just the organization of those, the outcomes and the probabilities. There are two different types of data that we've talked about multiple times. There's discrete, which are counting, and continuous, which are measuring. So let's just review that. Discrete are things that you count. You count people, you count cards, you count dice rolls, you count flipping a coin. Continuous are things that you measure. You measure height, you measure weight, you measure speed. So anything that has a label or you use a unit of measure, that's going to be continuous data. So this chapter, we're going to be talking about discrete random variables, and then we're going to follow up in the next chapter with continuous random variables. So discrete has a finite number of countable things. Remember, it's countable. What's the difference? Oops, sorry, that's my phone. What's the difference? These are going to be histograms that look like this. They're going to be bars. They're discrete things. You can't get a number. If you're counting coins, for example, you get a number 1 and you get a number 2. You count in between them. You count in between them. There's nothing that you can roll a coin and get a 1.67 head. Okay, you can average it out to that, but you can't get, you can either get 1 head or 2 heads. All right, a continuous would be your speed on a car or your height. For example, if you're looking at women in the US have a continuous height, and the mean is in the center actually, and it's around 64.5 inches, so that's 4.5. And you can have women of all different continuous heights. So if I say I have a woman that's 64.5 and another one, a female that's 65, there's a female in between there, and a female in between there, and a female in between there. That's a continuous distribution. So we'll take a look at that next chapter. So we're talking about discrete this chapter. All right. In this section, we're going to talk about these discrete. So remember, all probabilities have to add up to 1, and you can't have negative probabilities. Your probabilities always have to be between 0 and 1. Right, so we're going to calculate also the mean and standard deviation. So you want to take a look at this. And I'm going to highlight this box because it's super important in how we're going to do these formulas. Sorry, that's a little ugly, but anyway. So you want to put a little star around it or highlight this box. These are our 2 formulas that we're going to calculate today. Basically, we're going to have a x, which are our outcomes, and a probability that corresponds to that. The x's are going to go in list 1, and the probabilities are going to go in list 2. Then we're going to multiply the lists together, and then we're going to sum that up. You may want to write this down to find the sum function because you haven't used it for a while. You're going to do second, stat, and arrow to math, and it's number 5. So let's write that down. So for the sum function, you're going to hit second stat on your calculator, and then you're going to arrow over to math, and then it's number 5, the sum. Okay, and we're going to be using that sum function throughout this chapter, so jot that down to where the sum function is, and I'm going to also show it to you as we go through the examples. Then we're going to do a standard deviation. Here's the formula. We're going to take those x's that are in list 1, find the mean up here, put that in, and then multiply by the probabilities, which are in list 2. I have detailed instructions here. You're going to put x in list 1, probabilities in list 2, they're already going to be there from this problem up above from finding the mean. In list 3, we're going to type this exact thing, and then we're going to sum them up. And then that would be the variance, and then we'll square root our answer to find the standard deviation. All right, so we're going to do 2 things here today. We are going to calculate the, sorry. I want it to be just one page. Okay, sorry. First, we're going to, okay, so we are going to find a probability distribution for a single die roll. So we're going to start easy. So here we go. So the outcomes are 1, 2, 3, 4, 5, 6. Those are the outcomes when you roll a single die. You can get 1 through 6. The probability for each of those outcomes, 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. So basic probability distribution. It's nothing new. We're just organizing our outcomes and our probabilities. Now we're going to find the mean, variance, and standard deviation. To do that, we're going to excuse me, to do that, we're going to put them in our graphing calculator. So you're going to get your graphing calculator out. This is going to go in list 1, and this is going to go in list 2. So let me pull up my calculator here, and I'll make it bigger so you can see. And I'm going to do stat, edit, and I'm going to go to list 1, and I'm going to put my outcomes in. So 1, 2, 3, 4, 5, 6. Those are my outcomes. And then I'm going to go to list 2, and I'm going to put in my probabilities. So my probabilities are 1 divided by 6, 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 and 1 divided by 6. They're all the same. All right, and then what I'm going to do is I'm going to go to the top of list 3, and I'll show you another way to do this also. I'll show you 2 ways to do this. I'm going to go to the top of list 3, and I'm going to do list 1. So second L1 times second 2, which is L2. Oops. Sorry, I'm doing this on the calculator. On the screen. It gets a little funky. Okay, go back to the top of list 3. Let me clear that out. Top of list 3, right here. Make sure you're at the top of list 3. If you're down here, it won't work. So sorry, I hit a button. So L1 times L2. Okay, we're going to do L1 times L2, and then we're going to hit enter. All right, so you're just multiplying your probability times each outcome in list 1 and list 2, then quit out, hit second quit, and then you're going to sum that list 3 up. So you're going to go to second, stat, arrow over to math, go down to number 5, sum, and you're going to sum up list 3. And that's your mean. So pretty simple. So that's how you do your mean. I have the instructions on that front page. So basically you just put your stuff in list 1 and list 2, multiply them together in list 3, and then sum them up. Okay, now we're going to do the variance and standard deviation. All right, so go back up to list 3, and you don't have to clear this out. We'll just overwrite it. So at the top, all the way at the top of list 3, we're going to do parenthesis, L1 minus whatever that mean was. It was 3.5, parenthesis, squared times L2. All right, so make sure you're at the top, and you're going to type in parenthesis L1 minus the mean squared times list 2. At the top of list 3, hit enter, it'll calculate it, quit out, and you're going to sum up list 3 again. So you're going to go to second, stat, math. Number 5 is the sum, and sum of list 3. And the sum of list 3 is 2.91, so we're going to say 2.92. A handy thing is that you can use something called second entry, and it calls back your last problem. So you could reuse this function from finding the mean and just do second entry, and it calls up your last problem, and then it will redo it for you so you don't have to go back into that sum function. So the mean is 3.5 and the variance is 2.916. So now to find the standard deviation, we're going to square root. So second square root, and then this is also a handy feature. We're going to call up this last answer because that's the variance and we need to square root it. The answer is above your negative right here. It takes and calls and puts in your answer from the previous question into it so you don't have to retype. Just kind of a time saver. Okay, so there are 3 answers, 3.5, 2.92, and 1.71. So those are our 3 answers to our problem. We're going to write them down right here. So we have the mean is 3.5. The standard deviation is 2.92. And the standard deviation is 1.71. All right, and then on this one, it asks you to use a graph, to do a graph. So we're going to talk about a graph, but this is just a kind of a sketch to see what shape it is. So this is kind of a review of your shapes. So you have 6 outcomes, 1, 2, 3, 4, 5, 6. Mine is super messy, sorry about that. These should be all the same width. I'm just doing a sketch. And this is what we call symmetric, right? So this is symmetric. And we call this a uniform distribution because all of the bars are the same. Now, what we learned in our last chapter is in all symmetric distributions, the mean, median, and mode are in the center. So that is why we're getting a mean of 3.5 right in the center. All right, so can you roll a die and get a 3.5? No. These are what we call long-range averages. So if you did a die roll hundreds of times and averaged them out, you would get an average of 3.5. All right, let's take a look at the next one. All right, it says define as x. This is in flipping a coin. We are going to flip a coin 3 times. So the number of heads that you can get in flipping a coin 3 times is 0 heads, 1 head, 2 head, or 3 heads. So if I flip a coin 3 times, or you can flip 3 coins at one time, it's really the same problem. If I flip, 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 or flip them all at the same time, this is an independent probability that we learned from the last chapter. So it doesn't matter if you flip them separately or if you flip them together. All right, so I'm going to make a little tree diagram over here. So I'm going to have a coin flip. So there's my first flip. There's my second flip. And then here is my third flip. I'm going to show you later on in the chapter how we can shortcut this and get these probabilities quickly so that we don't have to do a tree diagram. So if you look at this, there are 8 outcomes in 3 coin flips. So my denominator is going to be 8. All right, so I want to go through and count. So how many of these outcomes have 0 heads? That would be tails, tails, tails. That's only 1. And I'm going to do the other easy one. How many outcomes have 3 heads? That's this one right here, heads, heads, heads. That would be 1. Then I want to find how many of these have 1 head and 2 tails. So number of heads, it would be 1 head. There's 1 heads, then I have to have 2 tails. So I'm going to go through here, change my color, and I'm going to do 1 head and 2 tails. So there's a head, tail, tail there. So that's 1, heads, tails, tails. Here's a tails, heads, tails right here. That's 2. And then I know there's another one. Oh, here it is. Tails, tails, heads. So the number of combinations with 1 head and 2 tails would be heads, tails, tails. I'll jot them down. Tails, heads, tails. And tails, tails, heads. So there is 3 of those. Okay, and then every probability distribution has to add up to 1, so that would be 3, 4, 5. So this must be also 3. And if you go through and look at it, you can find, here's the 3 for 2 heads and a tail, 2 heads and a tail, and then 2 heads and a tail here also. All right, so now that we have our distribution, we're going to go back to our calculator and put them in our calculator. Make that bigger so you can all see. So we're going to go into Stat, Edit, and List 1. I'm going to clear out List 1. So I'm going to go over to the top of List 1 and 2 and clear it out. You don't have to clear out List 3. You will overwrite over top of it, so don't worry about that one. So we're going to clear out List 1 and List 2, and we're going to put our x's in. So right here, we're going to do 0, 1, 2, 3, 3. And then the probabilities are, for this one, 1 divided by 8. Oop, I typed that in wrong. Sorry. 1 divided by 8, and then 3 divided by 8, 3 divided by 8, and then 1 divided by 8. Just whatever your probabilities were. Right, we don't have to clear this out. We're just going to write right over top of it. And so we're going to go to the top of list 3, all the way to the top, all the way. So all the way to the top of list 3. And if you want to, you can clear it out if you want to, if that bothers you. And then we're going to go all the way to the top of list 3, and we're going to tell it multiply, finding the mean, list 1 times list 2. So list 1 times list 2, we hit enter. This finds you the mean. It's like a weighted mean. The reason that you're not dividing by anything is because your probabilities always add up to 1. So those are your kind of weights. So this is basically really just weighted mean, where you multiply your lists together and then divide by the weight. But the weight is 1 because all probabilities add up to 1. All right, so after we multiply list 1 times list 2, we quit out. And then I'm going to clear my home screen. And then we're going to go to second stat, and I'm going to sum that up. So I arrow over to math, go down to sum, or you can hit the number 5, and you're just going to sum up list 3. Okay, there's the mean. So the mean of coin tossing, either heads or tails, because it's a 50-50 probability, is 1.5. So over a long term, if you flip 3 coins a whole bunch of times, you're going to average out 1.5 heads and 1.5 tails. And if you think about it, that's kind of common sense, because if you toss 3 coins and the probability is 50-50, you're going to average a half of 3. All right, so now let's go in and do our standard deviation, meet our variance and standard deviation. So back at the top of list 3, I'm just going to clear that out so you can see the formula in my home screen. So here we go. Let me hit enter. Okay. And then so at the top of list 3, your excuse me, your formula is parenthesis, and then we always do L1 minus the mean, which was 1.5, parenthesis, squared, times L2. Okay, so that's how you get the variance. Parenthesis L1, which is your x's, minus the mean squared, times L2. Hit enter. Oopsie daisy. What did I do? Oh, I made the mistake that everybody makes. I had my cursor here instead of up here. I'm going to hit clear and retype that. You'll see what. So here's what my mistake was. I thought I was up here and I was here. So if you get an error like I just did, then that's what's wrong. Okay, so let me type that again. So L1 minus the mean squared, And then you don't even have to put in the times. You can just put times L2, and I'm pretty sure it will work. So you don't even need to do that. Okay, so there's our variance. We're going to add that up and get the variance. So what I was saying before, instead of going back to the sum function and doing list 3, we really want to just do it again. So I'm going to do second entry. Nope. Sorry. Second entry. It calls up the last problem, and then I hit enter, and it sums up list 3. So that's our variance. And then I'm going to square root that. So I go to my square root, and instead of having to type this myself, I hit second answer, and then I hit enter. And there's my mean, standard deviation, and variance. All right, so I'm going to write those 3 things down over here. So my mean was 1.5, my variance was 0.75, and my standard deviation was 0.867. You can just do 0.872, that's fine. Okay, I'm going to look at my graph real quick. So there was 1/8, and then 3/8, and then 3/8, and then 1/8. So this was 0, 1, 2, 3. So if you were scaling this better than I did, this would be 1/8, and this would be 3/8, this would be 2/8. All right, so that's a little ugly, but I'm just trying to do this quick. Okay, so look at the mean. The mean is 1.5, right in the center, because this is a symmetric distribution. All right. Okay, so let's look at another one. Right, now we're going to do in the next lesson something called expected value, which is applications of this, and it's kind of like gaming questions, and we'll talk about that when we get there. So a box contains 3 $1 bills, 2 5s, 5 10s, and a 20. X represents the value of the single bill drawn. Okay, so X is going to be our money that we draw out. We're going to draw one time, so that's a money symbol. Sorry about that. All right, and then the probability of that X of that happening. All right, so let's look at what happens if we draw something out. So we reach in and we draw out. We can get a $1, a $5, a 10, or a 20. All right, let's look at our probabilities of getting one draw of each of those things. So we have 3, 2, 5, and 1. So inside here we have 3 plus 2 is 5. Plus 5 is 10, plus 1 is 11. So we have 11 bills inside there. Simple probability. And the probability of getting a 1 is 3. Probability of getting a $5 bill is 2, because there's 2 of them. A 10 is 5. And a 1 is 20. Okay, a $20 bill, there's only 1. Okay, so let's make sure this adds up to 1. So we have 5, 10, 11, 11 out of 11. All right, so then we just do the process. We're not going to worry about graphs. I just wanted to kind of show you that really quickly. We're going to go in. We're going to put them in again to our lists. So in list 1, we're going to go up at the top of list 1, and we're going to go and put in a $1, a $5, a $10, and a 20. Okay, so those are our choices. I'll make this bigger so you can see it a little bit better. And then we're going to go into list 2 and put our probabilities. Okay, so for our probabilities, we'll just follow along. It was 3, 2, 5, and 1. Okay, so it was 3 ones, so 3 divided by 11, 2, 11, 5 out of 11, and then 1 out of 11. Right, and so those are our probabilities. We just put this in list 2. So 3, 2, 5, and 1 out of 11. Oop. Okay, and then at the top of list 3, you're going to go to the top of list 3 and do your list 1 times list 2. Okay, so I'm going to go to second, went too far. Second list 1 times second list 2. And that is my answers for my mean. All I have to do is quit out and sum those up. And I'm going to do second stat, math to my sum function, You can go to 5 or arrow to 5, and you're going to sum up list 3. Okay, so there's my mean, 7.54. Now I go back in my lists, and at the top of list 3, clear that out so you can see my, okay, go back to the top. Remember, I made that mistake where I was highlighted here instead of here. So I'm going to do parenthesis, L1 minus, oh, not minus, minus the mean. The mean was, what was the mean? 7.54. I can't remember now. I'm hoping. All right, so squared, and then you don't even have to do the times. You can just do list 2. So it's always parenthesis L1 minus the mean squared times list 2. Let's hope I got that mean right. Okay, quit out. I did 7.54. I should have put 7.55, but that's okay. All right, call back my last entry because I just really need to resum list 3 again. And there's our variance. And then remember the answer to the standard deviation. We can call back this last one by hitting E and S for our answer. And then we have all 3 answers there. All right, so let's go through. I kind of messed that up a little bit. So right here. Okay. All right, so my answers for the mean, 7.54, 29.7, and 5.54. There's our 3. All right, last example. These formulas, yeah, that's our last example, sorry. These formulas are used a lot in business for long-term averages and applications. So if you're going to go into a business and major in business, you'll be using this formula for long time amounts of rentals. Like when I used to waitress a long time ago, our manager, because I worked at a franchise, our manager would get this data and saying, okay, we're averaging this many appetizers. You need to push this many appetizers. You need to push this type. On average, our restaurant compared to the other franchises is low in I don't know, fried pickle appetizer. So try to push these new appetizers because we need to increase our sales. And the managers at all these franchises would get this data from the other ones, from the other restaurants in the franchise, and you would try to make sure that you're at least meeting your quota or your average. Okay, so it says during the summer months, a rental agency keeps track of the number of chainsaws it rents each day for a period of 90 days. So if you just add this up, this is 90. All right, the number of chainsaws rented per day is represented by X. This one is just a probability distribution. I just wrote it vertically so you could see the difference. So this is going to still be our list 1. The results are shown here. Okay, so compute the probability for each. So if I rented 0 chainsaws for 45 days, the probability is 45 out of 90. 1 chainsaw for 30 days, probability 30 out of 90. 2 chainsaws is 15 out of 90. So this is just all going to be over 90. You don't even have to simplify the fractions right now. You can just, it'll do it right in the calculator for you. So let's go through and put it in our calculator. This is our last example. Make this bigger. So let's see, stat, edit. I'm going to go through and clear my lists now. So you can just start out and do this real quick. Okay, clear that list. And I'll show you another trick too when doing these for our last one. So, okay, so our X's are just 0, 1, and 2. Not that long for that one. Okay, and then our, oh, 2 didn't type, sorry. There we go. Right, now our list 2, the number of days on that, let me go back, was 45, 30, and 15. And then I'm going to have to divide by 90. So here's a little trick. Instead of typing each one divided by 90, which you can do, I'm going to show you a little trick. I'm going to put in just the X's. Oops. Hold on a minute. Sorry. Wait a minute. I'm going to show you something. I'm just going to put in just the x's here, 45, 30, and 15. I don't know what I was doing there. Okay, so I'm going to type in 45, 30, and 15. And then each one of these have to be divided by 90 to make the probability. So what I'm going to do is kind of just overwrite list 2. It's kind of a shortcut. Since all of these have to be divided by 90, I'm just going to go to the top of this and say at the top of list 2, super sensitive, sorry. Let me go to the top of list 2 and just say, hey, take all of list 2 and just divide it by 90. And it saves me from typing in that denominator over and over and over again. So you can put your numerators in and then go back up and rewrite over list 2 to get them all divided by 90. If you don't want to do that, that's fine. Just put in 45 over 90 in each one. All right, then we're going to go to the top of list 3 and do list 1 times list 2. And there's our multiplication for our sum, second quit, second stat for our sum. Number 5. Should have cleared it out from that last one, but that's okay. And there's our mean. So on average, this is a long-term average. This rental company over the summer rents about 1 or 0.67 chainsaws. Do not, these are theoretical averages, do not round that to 1. Leave it as 0.67. Okay, so the mean is 0.67. Now we're going to find the variance and standard deviation. So back in our list, and you can clear this out if you want or not. I like clearing it out so you can see when I'm typing my formula in. So parenthesis L1 minus, I'm just going to say 0.67 parenthesis squared, and then you don't even have to put the times in. It'll automatically multiply it times list 2. Now we're going to add that together, quit out, just pull it back up, that list 3. You don't have to do it again. There's your variance, and then your standard deviation. Call up your last answer, and you're ready to go. Okay, so there's our mean, 5.45, 0.67, and then 0.7, oops, sorry. Our mean is, 0.67, our variance is 0.55, and our standard deviation is 0.745. Oh my gosh, sorry. So 0.67. Don't round this. This is a long-term average. So on average, you're going to rent out about 0.67 per day of these chainsaws. And then their variance was 0.56 and the standard deviation 0.75. And that's our lesson for the day.